Welcome back, students. In this video, we are going to prove these three trigonometric identities. Example 7. Prove that tan theta plus sec theta minus 1 by tan theta minus sec theta plus 1 equals to 1 plus sin theta by cos theta. Left hand side looks a little bit complicated, so let's start from left hand side. Here it is. Now, the denominator, no changes. In the numerator also, first and second term is same. We are working for this one only. For this one, we are going to use the formula, that is sec square theta minus tan square theta equals to 1. But be very careful, students, since there is minus present in front of 1, before using formula, you have to put a bracket. Then only use the formula. Okay, bracket is here. Now let's use the formula for 1, that is sec square theta minus tan square theta. Next step, again, there's no changes in denominator and the first two terms of the numerator are here. Inside this bracket, sec square theta minus tan square theta. It is in the form of a square minus b square, whose formula is a plus b, a minus b. So we are going to write part of this formula, a plus b, a minus b. So we have here sec theta plus tan theta, sec theta minus tan theta. And these two terms we enclosed by a small bracket here so that it can be expressed as a single term. Now, another step, again denominator same. In the numerator, we have altogether two terms. First term consists of this bracket tan theta plus sec theta, and minus is here to separate this second term. Now, from both of these terms, we have tan theta plus sec theta common. So let's take tan theta plus sec theta common. Now left over is in the first term, this sec theta plus tan theta is already there in the common. So we put 1 here, minus, copied from here. And in this second term, we have sec theta minus tan theta left over. Moving on to another step. The denominator, there's no changes. In the numerator, the first bracket is same, tan theta plus sec theta. Now, in this curly bracket, we eliminate this simple bracket by multiplying it with minus, or we open the simple bracket by multiplying sec theta and tan theta by minus. So we get 1 minus sec theta. Minus and minus will get multiplied, so we have plus, it is tan theta. Now, here in the numerator, tan theta plus sec theta here, and in the another bracket, second bracket, 1 minus sec theta plus tan theta. Now in this denominator, we arrange the terms. That is, we bring this plus 1 to the first term and we take tan theta to the third one. We interchange the place of 1 and tan theta so that we get 1 minus sec theta plus tan theta. Now in both the numerator and denominator, we have 1 minus sec theta plus tan theta. The same bracket, they can get cancelled here. Now the leftover is tan theta plus sec theta. In right hand side, it is 1 plus sin theta by cos theta. Our answer is 1 plus sin theta by cos theta. So to get right hand side, we express both the trigonometric ratios, that is tan theta and sec theta, into sine and cos. So using the formula for tan theta, we have sin theta by cos theta, and using the formula of sec theta, we have 1 by cos theta. Let's take LCM. Both the terms have cos theta in denominator. So LCM is cos theta. Now in the numerator, sin theta plus 1 is here, which is right hand side. Hence, example 7 is proved. Example 8, this is the identity we have to prove. Let's start from left hand side. Here it is. Cot A plus cosec A minus 1 by cot A plus cosec A plus 1. Now let's work. In the denominator, the first two terms as it is, and for this one, we are going to use this formula. Cosec square A minus cot square A equals to 1. So 1 is replaced by its formula, cosec square A minus cot square A. Similarly, we work in the numerator also. The first two terms as it is, and for this one, we are going to use the same formula, that is cosec square A minus cos square A equals to 1. Hence, 1 is replaced by its formula, cosec square A minus cot square A. Next step, the first two terms of the denominator as it is, and the third term of the denominator, it is in the form of a square minus b square, whose formula is a plus b, a minus b. Here it is. Look here, a square minus b square, it is in the form. So we are going to use the right part, cosec a plus cot a, cosec a minus cot a. And the first two terms of this denominator is enclosed by a small bracket so that they can be considered as the single term. We work the same in the numerator also. This part, third term, cosec square A minus cot square A is in the form of a square minus b square, whose formula is a plus b, a minus b. So let's use the formula. Here it is, cosec A plus cot A, cosec A minus cot A plus b, a minus b. Also here in the first two terms, let's enclose it with a small bracket so that it can be considered as a single term. Next step. In this step, we arrange this cosec A plus cot A as cot A plus cosec A. In the denominator also, this portion, cosec A plus cot A, we have arranged it as cot A plus cosec A. Remaining portions, same. Now in the numerator, altogether there are two terms separated by this minus, and in the denominator also, altogether there are two terms separated by this plus. Now in the numerator, in those two terms, we have cot A plus cosec A common. So let's take these two brackets common and let's keep it here. Cot A plus cosec A common. And the remaining portion, we write it here. Cot A plus cosec A, it is already there in common. So in the first term, 1 is left over. Minus is here. And the cot A plus cosec A is already there in common. So left over in this second term is bracket cosec A minus cot A. Similarly, let's take cot A plus cosec A common from both the terms in the denominator and keep it here. Cot A plus cosec A common here. Let's write the remaining part. In the first term, this part is already there in common, so nothing is left over. So we put 1. Plus is here. And in the second term, this one, cot A plus cosec A, is already there in common. So leftover portion is cosec A minus cot A. Now only simplification left over. We can cancel the same bracket containing cot A plus cosec A from the numerator and the denominator. Now let's write the remaining portion. Now the simple bracket of this numerator is open by multiplying each term with minus. Here it is. 1 is here, and after multiplication with minus, we get minus cosec A. Minus into minus, it is plus here, and it is cot A. And in the denominator, 1 plus cosec A minus cot A. So we get the right hand side. Hence, example 8 is proved. Example 9. This is the identity we have to prove. In this identity, the first term of the left hand side, cos x by sin x plus cos y looks similar to the first term of the right hand side, cos x by sin x minus cos y. Similarly, the second term of left hand side, cos y by sin y minus cos x, looks similar to the second term of right hand side, cos y by sin y plus cos x. So we are going to transpose it. So we are going to arrange the terms of this identity. We are going to shift this second term of left hand side to the right hand side and the first term of right hand side to the left hand side. While we shift here, the sign becomes opposite. This cos x by sin x minus cos y was positive while there in the right hand side. When it shifts in the left hand side, it becomes negative sign. For this one, cos y by sin y minus cos x, it is positive here in the LHS. Now, when it shifts to the right hand side, its sign becomes minus. It is minus cos y by sin y minus cos x. Now we have formed new identity where left hand side is this part and right hand side is this one. So we are going to prove this identity. Let's start from left hand side. Here it is. In both the terms of left hand side, we have cos x common. So let's take cos x common. In the first term, denominator we have sin x plus cos y, and in the numerator cos x is already there in the common, so we put 1 here. In the second term also, in the denominator, sin x minus cos y, and from numerator the cos x is already there in the common, so here it is 1. Next step, let's take LCM within this bracket. So we have LCM part, sin x plus cos y, sin x minus cos y. While comparing the first term denominator and the LCM, there sin x minus cos y is not there in the denominator, so that one should be multiplied by sin x minus cos y, and in the second term it should be multiplied by this one, sin x plus cos y. Next step, this part, denominator part, it is in the form of a plus b, a minus b. We know the formula, a square minus b square has the formula a plus b, a minus b. So while comparing this part, it is in the form of a plus b, a minus b. So we use the a square minus b square. This is sin square x minus cos square y. In the numerator, let's open the bracket. While opening the second bracket, we have to multiply each term by minus. So we get minus sin x minus cos y. So plus sin x and minus sin x, they get cancelled as they are opposite in sign. Next step, in the numerator, cos y and cos y, they are like terms. So let's add it. And since both are negative sign, we have minus here. In the denominator part, this sin square x, we are going to convert it into cos. We know the formula to convert sin square x into cos square x, that is 1 minus cos square x. Similarly, we are going to change this cos square y into sine. The ratio is changed into sine by using the formula cos square y equals to 1 minus sine square y. Now, the numerator portion, the cos x will get multiplied to this minus 2 cos y. So it becomes minus 2 cos x cos y. In the denominator, we open the bracket and the second bracket is opened by multiplying each term with minus. That is minus 1 we get minus multiplied to minus we get plus here and sine square y. Here also we cancel 1 and 1. Now we have numerator as it is, denominator we have sine square y minus cos square x. Let's stop the solution of left hand side right over here. We come back to this step afterwards. Now let's solve right hand side also. Here it is minus cos y by sin y minus cos x plus cos y by sin y plus cos x. From both of these terms, let us take minus cos y common. So that in the first term we have in the denominator sin y minus cos x and the numerator it is 1 because this minus cos y is already there in the common. Now when we take minus common, this plus turns to minus and the cos y is already there in common, so we have 1 by sin y plus cos x. Now let's do LCM within the bracket. LCM is sin y minus cos x and sin y plus cos x. When we compare the denominator of the first term and the LCM, this sin y plus cos x is not there in this denominator, so 1 should be multiplied by this sin y plus cos x. Minus it is here, and the second term, this numerator 1 must be multiplied by this sin y minus cos x. Next step, the denominator here sin y minus cos x, sin y plus cos x. It is in the form of a minus b, a plus b, whose formula is a square minus b square. So we write it here sin square y minus cos square x. The numerator, let's open the bracket. First bracket it is open. Now the second bracket it is opened by multiplying each of the term with this minus. So we get minus sin y, minus and minus get multiplied. So we have plus cos x. Now sin y positive and sin y negative, they get cancelled. Next step, inside the bracket, the cos x and cos x are like terms, they are added, so we have 2 cos x. Another step, minus cos y is multiplied to 2 cos x, so we have minus 2 cos x cos y by sin square y minus cos square x. This is the solution of right hand side. Now let's go back to the solution of left hand side. It was minus 2 cos x cos y by sin square y minus cos square x. Now let's compare it with the solution of right hand side. That is minus 2 cos x cos y by sin square y minus cos square x. They are same. So we can write left hand side equals to right hand side. Both the left hand side and right hand side are equal here. So the identity is proved. Okay students, this much for now. Thank you.